I'm Dragan Savic, representing the Water Distribution Systems Analysis History Project. The purpose of this project is to document the history of water distribution systems analysis. An important part of the project is a series of interviews with engineers, modelers, researchers and practitioners who have made significant contributions to the field of water distribution systems analysis. Our interview today is with Professor Maria da Conceição Cunha. Maria is a professor in the Civil Engineering Department at the University of Coimbra in Portugal. She held various senior administrative roles at the university, including being the coordinator of the PhD program in environmental engineering. She's been vice chairman of the Scientific Council of the Faculty of Sciences and Technology of the University of Coimbra, and also an associate dean of the Faculty of Sciences and Technology at the university. She is currently a member expert of the National Water Council of Portugal and national advisor for the Water National Plan. She has over 30 years of research experience in hydraulic engineering with application to design and management of water systems and urban water systems in particular. This interview is being conducted on the 2nd of September 2015 in Leicester, UK, during the 13th Computing and Control for the Water Industry Conference. Maria, with your background in civil engineering and postgraduate work in aquifer management, can you tell us how you came to be involved in water resources systems analysis, and at what stage in your career did you decide this was the direction you wanted to pursue professionally?
So, thanks. I am very pleased to participate in this interview and to answer to Dragan's question. I have to say that my interest in system analysis began during my master's degree. In fact, I always feel I have been fascinated by the decision models, even in the high school. I don't know why in the high school. In the last year, I have a course in modern mathematics that included the decision modeling, very simple decision modeling. So in the master's degree, I have the opportunity to improve the knowledge about these subjects, and the opportunity to work with a supervisor that used to work in aquifer management or aquifer description, but he wants to move to aquifer management. So as I was interested in using decision techniques, we matched together, and it was my first work. Then when I went for my PhD degree in the University of Louvain, I proposed this subject to improve the work that I have performed in the master thesis. So I would say that my path to get involved in water distribution system analysis is perhaps a bit unusual, because I begin with aquifer management. And at that period, I have an important concern that I think that shaped my research in the future. It was the inclusion of the aquifer behavior into the decision models. Aquifers are described by tricky differential equations. So at that time, it was difficult even to have the numerical methods to establish the discretization of aquifers. So it was challenging to include the aquifer behavior. And at the same time, I noticed that the history of water system analysis applied to water resources is always the same. In the late 60s and during the 70s, normally we see the researchers fascinated by the methods, but they were used to the expense of big simplifications. And then I start to hear many complaints about the results that were obtained. And we were treated like mathematicians, even if you were engineers, like mathematicians that want to have very nice mathematical methods, but giving results that are meaningless. So that's why it's my first concern in my PhD thesis, and I think it shaped my research for the future. So I had my PhD in operation of aquifers for serving irrigation demands and urban demands. And I also noticed another aspect that also it was very important to shape my future research. It was the fact that my background was mainly in linear and non-linear optimization. And as such, I couldn't solve properly the design problems. So I went through the integer programming, and then I also noticed that this was not possible to solve design of water resources systems without using heuristics. And that's why I start the working in heuristics. So these two aspects shaped my research. And at a given point, as a civil engineer, knowing other different water systems, I had the curiosity to see what were the way taken by other systems. And as I told a while ago, the steps were always the same, beginning with big simplifications and evolve to more sophisticated applications. I think that is a way we have to follow. And I had a particular interest in the water distribution system. It was the time when we start to see some social movements with great expectations about water services. So mixing both things, I start to work in the field of water distribution systems. It's a short story.
Well, continuing on from that, you are based in Portugal, Southern Europe, and that particular area of the world has its own kind of particular problems in terms of water supply and water distribution systems. So can you tell us about any specific issues that are particularly important for that part of the world and how they influence your research at the University of Coimbra?
Yes, in fact, the southern countries are four seasons, very well defined, and normally we have rainy winters and in autumn too, but in spring and summer is sometimes very dry. And the point is, in Portugal, is a particular situation. The north is there is much more rain in the north than in the south. So I would say the global balance of water in Portugal is positive. But the point is that the water is not well distributed in space and time. So we have to structure the intervention in order to fit population. And another aspect very important in Portugal, that our tourist region, Algarve, has a very dry summer. So many different storage structures have to be constructed. Fortunately, they have also an important aquifer, and my university, my group, and we have developed a management model mostly about the water supply system, including the management and the location of resources from different sources, aquifers and reservoir dams, in order to fill the reservoirs of the water distribution systems. And they asked us to make this project exactly after a very dry summer of 2005. In fact, they spoke many times with us about this project, but it became real only when the dry year of 2005 rises. So I think I also work with some colleagues from Spain and from Italy, and I would say the same situation with enough water for the country, but we should have always management about during the year. Building infrastructures and having operation rules very strict to be able to provide water mainly in summer in south region and even because this south region is also a very important agricultural region. So this picture.
You have been very active in development and application of optimization models related to the design and management of water distribution systems, and in particular the development of simulated annealing optimization tools. Can you describe and summarize the major research questions, what the current state of the research is, and where your research in that area will focus in the future?
This use of simulated annealing is also part of the story. When I finished my PhD, I continued to have links with the University of Louvain and the core, that was the Center of Operation Research and Econometrics, was starting to work with a very special heuristic that was called simulated annealing. And then I became interested, and one of the reasons to work for them to work in this heuristic was the mathematical proofs of convergence to global optimum. Nowadays we know the meaning of all these in practical terms, but at that time it was a very important reason to work with simulated annealing. Then I was used, and I'm still used to attend operation research conferences, the World Conference of IFORS and the European conferences, and I heard one of the most proeminent researchers in tab search saying that the most important and tricky problems to be solved was the water distribution problem. So I mix both things and start to use simulated annealing to solve the water distribution systems problems. Starting, I think, as all the researchers in the field with very simple networks, gravity-fed networks, then evolve to more complex systems. And nowadays I'm very concerned with problems of uncertainty using robust optimization techniques, and also the concept of flexibility in engineering design. That is an approach trying to have solutions so that they can adapt to the uncertainty in environment, in market, and there the volatile markets we know nowadays, it's an important aspect. Also uncertainty in technology and in regulations, for example. And I think it's an important field of research to follow, to change from a large initial investments to incremental investments as the new information comes. And from the financial point of view, I think it's crucial, because markets and financial crisis, we all know about this. And so I think these aspects will take some more time in my research group, these two particular aspects.
You have collaborated with a number of colleagues, both in Portugal and internationally, on a wide range of interesting and creative work in the area of water distribution system analysis. Tell us a little bit about those relationships and your work together, and what made it so productive and creative.
Yes, I always think that it's important to have discussions, to have different views about the same problem, and even better if we are discussing with problems from different parts of the world. That was my case. I have worked with European colleagues in European projects and in other cost actions and so on, but I got involved also in projects in Latin America, like Brazil or Argentina, in India, for example, and also in Tunisia. And there is one thing, a conclusion that I have. There is always a matter of governance that shapes the problems in each country. Normally, I say, while in Europe we are very concerned in having resilient cities, I just finished a project, an European project, which case studies were located in Latin America. And for example, we find situations, regions in Brazil, where even a tap of fresh water exists. So this is very different, these are very different situations. So I think it's very productive to work with other colleagues. And I also feel that sometimes, as you live in a continent very developed, you don't see that we need other views, an interdisciplinary attitude to be able to solve the problems in other parts of the world. Because sometimes we need to convince the population that they need the water distribution systems.
You have mentored and supervised a number of MSc and PhD students at the University of Coimbra. Can you tell us a little bit about your experience of working with these students, and how do you come up with the topic? What's the relationship supervisor and student?
Normally, the subjects are already defined in the projects that are already financed, or European projects or our national projects. Normally, we work like this, unless someone brings to us some important subject. For example, I had a student from the University of Algarve in the south, presenting a very interesting subject about the location of monitoring points in the Algarve aquifers. And in fact, he was a brilliant student, so it was outside of my projects, but I felt it was a very interesting subject, and in fact his thesis was very, very good. Also, I have some PhDs. I had some PhD students in the scope of agreements between Portugal and Tunisia, for example, or Portugal and Argentina. And then the subjects, sometimes I propose, but then they should be adequate to the local needs in the water field.
Finally, a general question about future for the research and for the water distribution systems analysis. Where do you see the profession heading over the next 20, 30 years?
I think, in spite of huge developments in the field, we still have room to develop many different aspects. For example, in the formulation of the problems. The first concern I mentioned in this interview, I think we still need to evaluate the impacts of modeling, of simplifications, of the assumptions we make. Another aspect linked to the formulations is the maybe we need a new vocabulary closer to stakeholders for them to help us to formulate the real problems, to create a terminology that is good for us but also good for stakeholders to help us in the formulations. Then from the point of view of algorithms, I think we have many things to develop. To be able to evaluate the performance of the algorithms. Another point is to link the mathematical characteristics of the problems to the performance of the algorithms and have benchmarking on this field. And also to try to have self-tuning and self-organized algorithms for being able to spread all over the world these techniques that are very powerful, as we know. Also the computer efficiency, so many different things that are very important, the uncertainty, as I told a while ago. But there is one aspect nowadays that also is my concern, and I think the concern of many of us, is the way how the research funds are being attributed. They are too much centered in short-term market needs or market requirements. And it's necessary to know that in the universities and in the research center, we need time to mature our research. Sometimes the research is a long-term commitment. And we are now always speaking about research and innovation. And it seems that going from research to innovation is a linear process, is a straightforward process, and this is not true. We know that creativity, inventivity, it's a matter of research, but innovation, it's a matter of organization, of culture, I would say of creating an innovation ecosystem. Because in research we need time to skepticism, to value the curiosity, and if you are just trying to have products for market short-term needs, we can harm the potential of research. So I think we all researchers should discuss this subject in a deep way, in a deeper way.
Great. Thank you very much, Marie.
Thanks.